Welcome, and thank you for joining MinIO's Technology Feature Series. We're pleased to present MinIO's key encryption service in this installment. For those interested, our next installment will be on the Sidekick load balancer. My name is Jonathan Simons. I'm the CMO over here at MinIO. A few housekeeping notes. Everyone is muted. However, we will be taking questions over the chat function. Please feel free to ask them. As you have them, we'll address them all at the end. We expect and encourage a healthy Q&A. We'll be making the recording and slides available to you to share with your colleagues. During our presentation this week will be Andreas Auernhammer. Andreas is an engineer with MinIO and is focused on all things security and cryptography. Andreas's work has covered S3 server-side encryption and analysis and a formal verification of the underlying cryptographic constructions. He's published several blog posts on security, including vulnerabilities created with the combination of encryption and compression. Andreas has his master's in science in IT security from Technical University Darmstadt and a bachelor in science in computer science from OTH Regensburg. Without further ado, I'm going to turn it over to Andreas to take us through an introduction to KES.
Thanks for the introduction, Jonathan. So, welcome everyone to this KES overview webinar. What I want to do is I want to quickly talk about who we are and what we do, and then dive into what KES is, what you can do with it, how does it work, and finish with a quick demo showing a KES deployment and how it kind of connects to other parts of the system. Yeah, so MinIO is a high-performance object storage. You can think of it like AWS S3, but for the private cloud. And it scales very nicely to in a big infrastructure to petabyte scale. And we build the MinIO server and the MinIO client and SDKs for various programming languages around the S3 API. And we also kind of maintain an ecosystem around the MinIO server. One of those projects is KES. So, and we at MinIO itself is kind of the standard for the private cloud. We are mostly deployed on machines in the US and Europe. And here you can also see like we almost achieved 400 million Docker pulls, and also kind of have a healthy and active community. So we almost passed 8,500 Slack members and 550 developer contributors for our open source project. And this is because MinIO is a high performance solution that provides enterprise grade features. Obviously, MinIO implements the full S3 API, so any S3 client application that works with AWS S3 will also work with MinIO. And we also are the kind of only S3 object storage implementation that provides S3 select. So you can kind of use MinIO to use SQL-like query language to parse object records and filter them. But today I kind of want to focus more on the features around security and cryptography. So these are kind of the encryption-related features, and specifically I want to talk about how we approach the problem of distributing keys to MinIO such that MinIO as the S3 server can encrypt those objects using secure encryption implementation. And therefore, it's important to know what makes us different. So MinIO is designed as a simple system such that it can scale. And yeah, it's a kind of a standalone binary that can be packaged as a container and then run on Kubernetes. And we are actually kind of the most popular object storage on Kubernetes. So yeah, we basically, it fits also in the picture of being kind of the leading vendor in the private cloud. And the biggest differentiator is that MinIO is high performance. We are the fastest S3 compatible object storage. So yeah, this also leads us to kind of our CAS project, because we actually saw that CAS is, or a solution like CAS is needed for the private cloud, because MinIO is a high performance application that also demands integration into high performance solutions in other aspects of a private cloud. And therefore, I want to kind of talk about how we think the key management and key distribution should work on the private cloud. And we think that should be very, very similar. The experience should be very, very similar to the public cloud experience. So on the public cloud, like AWS S3 or Azure, you have a cloud KMS, and you as the developer, you just connect to the cloud KMS. You don't have to worry about the KMS being kind of alive, being managed and scaled. So you just can use the KMS. You don't have to worry about scaling that based on the load on the entire infrastructure. However, on the private cloud, the picture is a little bit different. There, there are private cloud vendors, KMS vendors who provide a KMS solution. For example, HashiCorp Vault. But those solutions are kind of isolated silos. So it's more like you put those systems or those components in your system, and they don't really scale. They more are kind of a box that keeps your secrets private, but does not really fit into the Kubernetes like environment where you kind of have containers spun up on demand. And that is actually where we as MinIO saw that as such a KMS vendor does not fit or does not provide the high performance that we need. And therefore we started our CAS project, and we try to make certain things different. And that leads us to the CAS design goals. So we try to build CAS as a simple system that scales and is secure by default. So by simple, we mean that CAS should be easy to easy to deploy, easy to manage, and easy to automate for the average developer. This is kind of different to a traditional KMS implementation, which is more focused on a security team, DevOps team that installs this KMS solution and has some learning curve. We try to kind of make that aspect simpler. And obviously, we also want our solution to be scalable in automated environments, especially Kubernetes, because that is the biggest downside of such existing KMS implementations. They are either very hard to deploy on Kubernetes, or it's actually almost impossible to get those as containers running inside such an orchestrator. And obviously, because we try to build a solution for managing cryptographic keys and distributing them to applications. It has to be secure, and we try to build that by design and by default. So how did we try to achieve those goals? So CAS is a stateless and self-contained system with an idiomatic REST API that uses a universal authentication mechanism. So what does that mean? CAS is a small binary that can be easily packaged as a Docker container, and it is completely stateless, such that you can start such a container, kill it, restart it, and you don't have to worry about any state maintained by this container. And you can also spin up multiple replicas of such a container, and they don't need to be aware of each other. And those containers provide an API for the clients, and this API is kind of a very simple, easy to consume REST API. I will talk about this a little bit later on. And probably a little bit about the most vague point on this slide, the universal authentication mechanism. So on the internet, there's one mechanism that works across all platforms, all architectures, and all programming languages, and that's TLS. And CAS uses just TLS for authentication, especially immutable TLS. So CAS relies on this kind of authentication mechanism that is supported by not just a specific SDK, but any tool like curl that can speak HTTP and TLS. And this mechanism, or basically using this mechanism, allowed us to build a stateless and scalable solution. So now we know a little bit about how CAS was designed and what goals it tries to achieve. Now I want to kind of talk a little about when to use CAS and for what. So CAS is designed to make the integration for applications into an existing KMS infrastructure easier. So let's assume you have a existing infrastructure with a central KMS like HashiCorp Vault or Gemalto KeySecure, and you want to connect your applications to this KMS. With CAS, you can do that kind of in a isolated way, such that you don't really have to develop integration into your application. Instead, you can just kind of attach a component consisting of your application and CAS to this existing KMS infrastructure. And the second kind of typical use case, which also we use, is using CAS for automated key distribution in distributed systems. That refers to Kubernetes. So when you basically want to spin up CAS instances, or basically services that provide key management functionality on Kubernetes, you could try to do that with, let's say, HashiCorp Vault, but the problem is HashiCorp Vault has to be unsealed, so initially configured, unsealed, then it can be used, but eventually it gets sealed because, for example, the container got shut down by Kubernetes. Now you have to unseal it again, and this is kind of a difficult and complicated process. So CAS is designed to make this experience much smoother. And then the last kind of point here is that CAS can provide KMS functionality to high-performance applications because it's scalable. So CAS can act as a load distribution layer such that each application has its own set of CAS servers and don't need to hit the central KMS, because when it comes to high performance applications, those can easily kind of overwhelm a central solution, central KMS solution that has to serve requests for multiple such high performance applications. But of course, there are also cases where CAS is probably not the ideal choice. And this is when you run on the public cloud. It's not like you cannot use CAS there. It's more like you don't really get that much of a benefit, because the cloud providers already provide you a cloud KMS, which is managed for you. So basically they have their own version of CAS, and it's their responsibility and their job to keep that infrastructure alive and scaling. So there you don't basically have to worry about that. You can defer that responsibility to the cloud provider. And there's also the case that you may have a small scale application that doesn't possess much data. In that case, you can still use CAS, but there it's kind of a trade-off between having decoupling the application from the central KMS versus an additional component, specifically CAS, in your infrastructure that you have to kind of take care about, and making sure that it's alive, properly configured. So now I want to talk a little bit about the typical deployment, so typical CAS deployment, and I have a slide that shows how most of our customers use CAS. So on the left side here, you can see a bunch of applications that use the S3 API to talk to MinIO. And MinIO basically does the S3 operation, so create an object, delete an object, get an object back to the application. And eventually, MinIO needs to encrypt those objects. And therefore, it requires encryption keys, so data encryption keys. And those data encryption keys are coming from CAS. And therefore, MinIO talks to CAS over TLS. And CAS will hand out unique data encryption keys to the MinIO server. And CAS itself will basically have a root of trust, the central KMS on the right here. And the master keys are basically stored there. So the entire state is inside the central KMS, but the stateless key cryptographic operations, for example, generating a new data key or decrypting an existing encrypted data key, that can be handled by the CAS server. And as you can see, you have like multiple applications, you have multiple MinIO servers or MinIO clusters, depending on the size of your infrastructure. And you have also multiple CAS servers, which you can easily scale on Kubernetes, but you just have one central KMS, and this can be managed by a dedicated security team or DevSecOps, and you don't have to worry about scaling that piece of infrastructure. It's just like the root of trust, and the security team can control it. So how does MinIO talk to CAS? We have the CAS CLI that uses the CAS server API to basically do the cryptographic operations. And here you can see the CAS CLI. It takes just 3 environment variables, the CAS server endpoint, which is in this case our play.min.io instance at port 7373. And that's our play instance for the public to play around. And then also the TLS private key and TLS certificate. And this basically refers also to what I said previously about using MTLS for authentication and access control. And then we just use a CLI command here, CAS key derive my key, and pipe it to GQ. And what it does is it requests a new data encryption key that is derived from the master key named myKey. And the responses are plain text and the ciphertext pair. And the plain text is basically a 256-bit random value, which you can use for, say, AES, encryption with AES. And the ciphertext is the encrypted version of that plain text key, which you would store alongside your, the encrypted data. And there's also a decrypt API, which you can use to decrypt the ciphertext and get the plain text back. And if you want, and the CLI basically uses, is very close to the KES API, the KES server API. So here I did the same operation with curl. And again, I just passed the TLS private key and the TLS certificate. And basically hit the play.MinIO instance and use the v1/key/generate API. So that's for generating or deriving data keys. And I used here the my key again as a parameter. And you can see the output is very similar. Of course, it produces a different value because the derived keys are unique. But the output itself is quite similar to the previous CLI output. And instead of kind of going through each and every API call, which we actually have a tile list on our documentation, on the KES wiki, I want to proceed with a quick demo that shows how you can use KES in your infrastructure. And here you can see on the right side of the screen here, you can see KES server. I've started that with KES server --config and then a YAML configuration file. And there's also a second version of this KES server started on port 7374, so on a different port, but it uses the same configuration. So this basically is a second replica you can think of. And as you can already see, it's connected to a HashiCorp Vault instance running on localhost port 8200. So this is basically this Vault instance here. So here this is basically acting as the central KMS. Of course, for this demo setup, it's just here on localhost. And then there's also a MinIO server running here, which will use KES for encrypting objects. And here on the left side, what you can see is this terminal window here is the Vault client. So here I can use, I directly talk to Vault, but we will come to that. So what I will do is I will first just do a basic command as I showed before. So there's this KES key derive my Manio key. And if I run that, I get kind of a similar output as before. Here's a plain text, here's a ciphertext, and that basically was acted as the kind of a quick check that everything is working. And now what I can do is I can start tracing the audit event stream of this KES server. So if I do that, I basically see a table view that shows me what's happening on this KES server here on the right. And if I do this operation again, you will see an audit event that says, yeah, there was a request that for generating a new data key from the MinIO key, MinIO master key. And if I go to Vault, this key actually exists. So, for example, I can type Vault MinIO, and here you can see there are two keys. One is called my key, one is called my MinIO key. This is the master key we used in the previous operation to derive a data encryption key. So what I do now is I upload objects to this MinIO server. And this MinIO server is configured with the CAS endpoint on port 7373. And it will use that CAS server to encrypt objects. It's configured to use auto encryption, such that every object uploaded to this MinIO server will get encrypted. And for each object, MinIO will fetch a new data encryption key from CAS. So if I run that command, it succeeds pretty fast. And you can see here, there are a lot of generate key operations. And MinIO now has basically stored a set of objects in the bucket test. And I can list that bucket. I can use mcls local test. And then there are basically some source code files. And if I go to the trace view, you can see now decrypt operations. So basically for decrypting some metadata, the MinIO had to talk to CAS again to decrypt those metadata entries with the using basically the master key here. And so what you may also see is that there's a second CAS server that I showed you before, but you can also watch the second CAS server with a trace command. So here we see the trace output of the second CAS server on port 7374. And if I run that command again, here, you see output on the left here. This is decrypt operations, just happened a second ago. And but no output on the right. And this is because those two CAS servers are completely isolated. They don't talk to each other. But I can basically point MinIO to the second CAS server instance by stopping it first, and then setting the KMS CAS endpoint to the same host, but on a different port, and then starting MinIO again. And if I now run, let's say, the ls command, you will see output here on the second CAS server trace. And this CAS server here basically just picked up the my MinIO key from Vault because it was not used before, and then kind of decrypted the data encryption keys, encrypted data encryption keys. So this shows that you can basically have multiple isolated systems of CAS, and you can basically talk to each one of those systems, each one of the servers, and if they are configured the same way, they will give you the correct responses. So they can decrypt the same data, they can encrypt and produce data that can be decrypted by a different server. So you can basically use those two CAS servers like two replicas, really. And now I want to go and look at how I configured this CAS server. So therefore, I look at the casconfig.yaml. So this is the YAML file I used as configuration file for those two CAS servers. And so the first entry is just like where this CAS server starts. So by default, it starts on any IP on this host on port 7373. And then there's this root identity, which I use basically to perform the tracing operations. But the interesting part starts basically here. So here's the TLS configuration. So the CAS server has a TLS private key and a TLS certificate, which is called cas.key and cas.cert. And it has a cache configuration. So each of those CAS servers will basically keep some cache entry of the master key and basically forget those entries if they are not used after 10 seconds, and forget any such entry after 30 seconds. So those two CAS servers cannot run for longer than 30 seconds without the central vault instance being alive and active. So let's say if the vault instance got sealed, then those two CAS servers will stop processing data after at most 30 seconds. And of course, you can adjust those values based on your requirements. And now, then there's this policy section, which defines what operations the MinIO server here can do. And this MinIO server can basically call three APIs. This is the key create, key generate, and key decrypt API with the MyMinIO key. It cannot use any other key. So, for example, it would not work with the my key here. It will only work for the MyMinIO key. Every other key would be kind of, or MinIO would not have access to any other key. And here you can see that this policy is basically assigned to identities are assigned to this policy. So this policy applies to all of those identities. Here I just have one, and this identity is the MinIO identity. You can see that if you type CAS tool identity of search, and it will print the same identity. So this is the client TLS identity of MinIO. So this MinIO instance has a private key and a public certificate, and the hash of the public key in the certificate is this value. And so, this way, CAS can match the MinIO server to this policy here, and can basically enforce those the policy restrictions here. And and then there's the connection to the central vault, which is here defined in this keys section. So here we basically define how to which central system CAS connects. In this case, it's HashiCorp Vault, running on the local system on port 8200, and it has a prefix called MinIO here. So the prefix is an arbitrary value. It basically acts as a kind of isolation between so what you can do is on HashiCorp Vault, you can have multiple kind of folders or prefixes, and you can create policies such that specific applications can only write to specific folders. Here you can see that by the vault policy here. So the policy for MinIO for CAS is it can create, read, and delete any value inside KV/MinIO. So because of the star here, so it can create any value inside KV/MinIO, and it cannot read outside MinIO. So if there would be a folder or a key value prefix KV/foo, the CAS servers would not be able to read or create or write to this location or any other kind of location apart from MinIO. This is enforced by Vault through this policy. And by this prefix, I tell CAS, don't write to KV directly, write to KV/MinIO. And then there is the app role ID, app role secret, and the retry delay. So this is basically just the access credentials for CAS to talk to Vault. In this case, I use app role. So here you just provide the secrets the Apple secrets, which you can obtain from Vault. And then there's also the status ping. So CAS will monitor the status of Vault every 10 seconds here. So it can, of course, decrease that to 5 seconds or increase it to 30 seconds. And what CAS will do is it will ask Vault, hey, are you alive? And are you not sealed? And is everything fine? And Vault will respond appropriately. And if, for example, HashiCorp Vault got sealed, then CAS will basically notice that after here 10 seconds, or most 10 seconds, and basically stop all operations, because it will clear the cache, it will clear this cache here, and then every operation, basically every derived key operation, for example, would need a master key, which is not in the cache, so CAS has to talk to HashiCorp Vault again, but Vault will respond with, no, I'm sealed, I cannot get you that information. And this way, you can basically ensure that if something happens on the Vault side, for example, a sealing event, then you, after a fixed period of time, CAS will notice that and stop delivering secrets to its applications. Yeah, and we can actually try that. I can stop Vault here. I can say Vault operator seal. And now here you can see Vault is sealed now. And if I, for example, go up here and try derive my MinIO operation again, it should fail after at most 10 seconds, because the MinIO server now should have noticed that the Vault instance is not able to function anymore. So if I try that, here you see fail to generate data key, the key store is sealed. So basically, at that point in time, the CAS server instance here, or specifically this one, has noticed that Vault is not able to function anymore and wiped its cache such that it gets unusable until you unseal Vault again. Yeah, that would be the end of this demo. So I think we can proceed to Q&A. So if there are any questions.
Yeah. So one that just came in, does CAS have privileges to unseal? And do you need to set any policies for that?
Yes, CAS has the ability to unseal data encryption keys. You define that in the policy section. So here, CAS, here you specify that the application can decrypt a data encryption key protected by my MinIO key. And this, if you remove that this line here, then you can encrypt or generate new data keys, which you can use to encrypt data, but you cannot decrypt anymore. So everything you encrypt, so if you forgot the plaintext key at some point in time, then you cannot get the data back.
Got it. So this was Vault. Are there other KMSs that MinIO has tested against or validated against?
Yes. So we have an implementation for HashiCorp Vault, obviously. We also have an implementation for a combination of AWS KMS and the AWS Secrets Manager. So you can also use a cloud managed KMS as well. And we also have integration into Geometric Key Secure, and we are currently in the phase of doing or deciding how to proceed with this integration with Gibraltar, respectively Thales, and get this out. This is currently merged in master, but not released yet.
Got it. Another question that just came in: if the master key is rotated in the backing KMS, does the cached CAS entry get invalidated automatically?
The master key cannot really. So the rotation works a little bit different here. So I'm aware of the fact that many people use the key rotation feature of the central KMS to rotate the master key periodically, let's say every year, for example. But in this case, what you would do is you would create a different key at the KMS. Let's say you have a MinIO key, and then you create the MinIO key version 2. And those keys just differ in the name. So you cannot rotate the key like using the typical KMS API, but you have to kind of make a second entry and rename that entry. But there's tooling for that it's kind of similar experience.
Got it. Another question that just came in, how do I run CAS on Kubernetes, and can I run CAS on Kubernetes?
Yes, so you can run CAS on Kubernetes. We provide Docker container on or Docker image in the repository. So you can just spin up this container and provide such a YAML configuration file to this container, and then it works on Kubernetes. What you can also use is for automated certificate management. You can use the Kubernetes certificate API, and if you want to use Kubernetes, for example, to keep high availability set of CAS servers running, you can, for example, configure a horizontal autoscaler such that Kubernetes will adjust the number of replicas to the load in the system. And if there's more load, it will increase the number of replicas. If there's less load, it will decrease the number of replicas.
Got it. Are there limitations on how large CAS can be scaled to?
Not really. So CAS is completely stateless. So if you can have one replica, you can have 100, you can have 5,000. The limitation just comes from like your physical hardware and how many connections your central KMS can handle. So because CAS has to talk sometimes to the central KMS, let's say here in this case every 30 seconds at least. So there are some limitations, but these are just like enforced by other environments, so the central KMS and the available resources.
Got it. You mentioned, so this is available on a GitHub repository, and it's just MinIO/CAS, is that correct?
That is correct, yeah. GitHub/MinIO/CAS.
Yeah. And then in terms of licensing, how is CAS licensed?
CAS is open source and licensed under AGPL v3, so it's an open source project.
Good. Okay. And I think also in that question is around bundling, but yes, it comes bundled with the core MinIO server, but it's licensed AGPL v3. Okay.
Yes, correct. Yeah.
Got it. All right. I don't see any other questions right now, so I think we'll probably conclude. I want to thank you, obviously, for a great presentation today. Really covered a lot of detail and a lot of technical detail. So I'm sure that people who watch this live, but also will watch it on recording, will get a lot out of it. Just a reminder, our next installment in this series, the feature series, will be Sidekick. And that will be coming up in a few weeks. So keep your eye out for registration for that. And we will continue to do these throughout the year, selecting key engineers to present key features of the MinIO object storage suite. So thank you very much for suite. So thank you very much. We really appreciate it. And we look forward to seeing you on future calls.